Transistor characteristics and input and output characteristics, how the transistor will activate. In that case, we got the three regions like a saturated region, cutoff region, and as well as a active region. And after that, transistor, how the transistor acts as a switch. Whenever the transistor is operated between the cutoff region and saturated region, whenever it is operated in cutoff and saturated region, whenever that transistor will act as a switch. Now means when the transistor acts as a in cutoff region as a off position, if in case it is operated in a saturated position, it will be considered as a switched on position, and earlier we discussed about that switch. Now if the transistor is operated in active region, then that acts as a amplifier. Transistor is operated in a active region, then that acts as a amplifier. What is amplifier? Means for example, while we are speaking in the microphone, maybe our voice is less, but when we are talking in the microphone, we can hear the loudness of sound from the loudspeaker, more sound from the loudspeaker. The signal which is sent by us is amplified. That process of increasing the signal, the process of increasing the strength of a signal is called as a amplification. The device which is used to increase the or raise the strength of the signal is called a amplifier. When the transistor is operated in active region, then the transistor acts as an amplifier, uses an amplifier, and when the process of raise the strength of a signal, the process of raising the strength of a signal is called amplification, and the device which is used to increase or raise the strength of the signal is called amplifier. Here transistor as the amplifier, commonly for the amplification process in the amplifier, common emitter biased transistor we can use most commonly. So here this is the block diagram of amplifier. So here whenever the microphone which is used to like this is the microphone which is used to speak, and whenever we are giving the signal to this mic, means microphone, the signal is sent to the amplifier. The signal sent to the amplifier, and that amplifier will increase the strength of a signal. Amplifier increase the strength of a signal, and that amplified output we can hear from the loudspeaker. From the loudspeaker. This in the radio signal transmission, means a radio communication process like antenna, whenever the signal is sent by that, the antenna received the signal is very less. Whenever the received signal by the antenna is very less. Whenever the less, in case of watt, in case of means the signal will be maybe watt. So that if you want to hear that sound, the signal has to increase the hundreds times of that input signal. So here we can see that whenever the signal sent to the microphone which is received by some of the receiver in a watt, a small size of signal, that can be amplified by the amplifier. In radio communication also, in visualization, means everywhere we are using the amplifier. Everywhere we are using the amplifier for the sound wave versus the picture also. Whenever the signal strength is increased, for example, if in case of nowadays we are getting the DTH box, right? So setup box. In setup box also, whenever the signal is received by the setup box, some of the HD box also there, some of the normal box also there. Whenever we get the HD channels, means HD channels means we can see the more clear than the normal. Means high definition, means high signal it can be received. Means the signal amplified, the strength of the signal is increased by the amplifier. So that in case of that, whenever the amplification means the strength of the signal can be increased, the strength of the signal can be raised So that process is amplification, and the device which is used for that process is called a amplifier. This is microphone, and the signal whenever sent to the microphone, and it is a microphone sent the signal to the amplifier, and through the amplifier that sound signal or some whatever the signal we are giving the input, the input signal is amplified. That amplified output given to the loudspeaker, which can hear 100 to 1000 times of more sound whenever we can get. So that what is the working of, mainly we will use that, mainly commonly in the amplification process the common emitter transistor can be used mostly. So that what is the common emitter transistor, this is the circuit diagram for this is NPN transistor we are taking that is common base, common emitter configuration, means this is emitter, this is base, and this is a collector. So that here there is two type of amplifiers is there. First one is the current power amplifier, and another one is a voltage amplifier. In this case of what is power amplifier? Power amplifier means which can increase the strength of the power, means raise the power level, and according to the voltage amplifier which rise the voltage level. Then the working of a transistor as a amplifier, working as a transistor as amplifier. We know that the input and output characteristics of a transistor according to the common emitter configuration by giving the input signal whenever, once again I will repeat in fast forwardly. So whenever the input signal given to this, by changing the potential difference by keeping the VCE at constant, by changing the VBE we can measure the base current, and as well as here is also by keeping the fixed value at the IB, means current here which is passing that is IB, means base current getting fixed, making keeping the base current fixed, and we can see the we already draw the graph between the VC and IC by measuring the changing the fixed value of IB. We can change the VC, by that we can measure the collector current which is in the circuit. So that by changing the input signal is to be amplified connected with the VBE in seriously, means AC input which we are giving that connected in series connection, and so that with the biasing battery VBE, this one is the biasing battery VBE, this is VBE biasing battery, it is connected in series, and as well as a loud RL resistance, means this is RL resistance, this is input resistance. This is input resistance, this is RL resistance. Wherever load resistance, it can be called as a load resistance. RL means load resistance is connected in the collector circuit. This is primary circuit, this is base emitter circuit, and this is collector emitter circuit. This is the primary circuit and this is the secondary circuit. In the primary circuit, the load resistance is connected in the collector circuit. As the potential difference VBE changes with the time, potential difference across the between the base and emitter. Emitter is common bias, so that's why here the potential difference VBE changes with the time due to input signal base current IB and collector current IC, and output voltage VC changes accordingly. Means whenever what is meant by the active region, in the active region the base emitter junction can be forward biased and collector emitter junction can be in a reverse biased. When if the transistor in active region, in the whenever it is happen, when it happens that is base emitter junction will be in forward bias, means primary circuit is in forward bias, and the collector emitter junction means the secondary circuit junction will be in a reverse bias. Then only the transistor will be in active region. So that's why here whenever the VBE changes, means potential difference between the base and emitter junction changes, so that according to that the base current and collector current and potential difference between the collector and emitter junction, base current, collector current and potential difference between the collector and emitter will be changes accordingly, so that the signal can be amplified. Here the input and output voltages are both in opposite phase. Input and output voltages are both in a opposite phase. So that here we can get the negative sign whenever the voltage gain. In the voltage gain we can get the negative sign. So that here the once again when the potential difference across the base and emitter changes means VBE changes. VBE changes due in time with the time, then according to that IB means base current, collector current and potential difference VCE changes accordingly. So that we can get that current gain, we can get the values from this current gain. What is meant by the current gain? Current gain means is nothing but already we discussed about it, the ratio of output current to the input current. What is output current? Here the collector current is the output current. What is input current? Input current is the base current. So that the change in output current to the ratio of change in output current to the change in input current is called as a current gain, that is denoted with a beta. Here current gain beta, the ratio of change in output current to change in input current. That current is AC current, alternating current. So that the input current is IB and output current is IC, so that the ratio between the change in output current alternating current to the input alternating current is called a change in input alternating current is called as a current gain. So that here we can get that current gain can be denoted with beta. So beta is equal to delta IC by delta IB. Delta IC means change in output current by delta IB means change in input current. So here once again when amplification means to increase the strength of a signal, the process is called as amplification. The device which is used to raise the strength of the signal is called as a amplifier. Whenever amplifier is commonly in the amplification process, the transistor which is common emitter transistor can be used, and as well as there is a two type of amplifiers is there. First one power amplifier and voltage amplifier. The power amplifier is to raise the power level and voltage amplifier is used to raise the voltage level. So that in that working process whenever the VBE changes, when the VBE changes, the input AC input is connected seriously with the battery VBE, so that whenever the potential difference between the base and emitter changes with the time due to input signal, that is base current and collector current, and potential difference between the VCE, potential difference between the collector and emitter will be changes accordingly, so that we can get the current gain and the voltage gain and power gain. So that the current gain is the ratio of change in output AC current to change in input current is called a current gain. The next the voltage gain. The voltage gain. In that voltage gain we can see that here already we discussed about the current gain. In the voltage gain we know that the ratio of output voltage, the ratio of change in output voltage to the change in input voltage, that is we know that voltage means output voltage will be VCE and input voltage will be VBE. So the change in output voltage is delta VCE by delta VBE. Here we know that voltage V is equal to, already we discussed about that, V is equal to IR from Ohm's law. According to the Ohm's law, V is equal to IR. So that in case of VC in output current we know that the voltages are in a opposite phase. So that's why we can get that whenever the collector emitter junction voltage will be in minus IR. So that's why according to this output voltage means I means output current, RL means load resistance, at output resistance we can get that. From the signal we can get that output signal, AC signal. Then here minus RL of delta IC means delta VCE is equal to, means here delta VCE is equal to, in delta VCE voltage means the current is IC and delta IC, current change in current delta IC, and resistance will be RL. So we got that which is in negative phase, so that's why negative sign we can get that. So minus RL into delta IC by input VBE. VBE means what? here the input potential difference, it is at the input potential difference across the base and emitter junction. So that's why here input voltage is a delta VB, change in input voltage is a delta VB. So that's why here delta VBE is equal to input resistance is Ri. Ri is the input resistance, and delta here current will be delta IB, input current will be base current. So that's why Ri into delta B. So from that equation we can get that. But we know that from the current gain, beta is equal to delta IC by delta IB is equal to current gain. This is delta IC by delta IB. From that equation we are substituting, then we can get minus beta into RL by IRI. RL by RI remains constant and remains same, and delta IC by delta IB is equal to beta. So minus beta into RL by RI. So that the negative sign indicates that the input and output voltages are in opposite phase. Opposite phase. That is, input and output voltages are in a opposite phase. So here this is about a voltage gain. The next one is a power gain. Power gain means the power is equal to, we know that is a P is equal to V into I. P is equal to V into I means voltage into current or current into voltage. So that's why here power gain means it is denoted with AP, the ratio of output power to the input power. The ratio of output power to the input power is called a definition of power gain. So from that equation we can get that power gain is equal to current gain into voltage gain, means IV means power gain into voltage gain. From that equation we know that output power by input power. Output, what is output power? Current gain into voltage gain means I out by I out into V out. This is the current gain out, I out by into V out. So at the same time current gain means current out by current in, input current and output current. Voltage gain means output voltage by input voltage. So from that equation we can write that here we have that beta RL by Ri and as well as the delta IC by IB. We know that is equal to beta, beta into beta, beta square into RL by Ri. This is about power gain. So whenever the transistor is operated in active region, then the circuit will be in forward bias. The primary circuit will be in forward bias, means emitter base junction is in reverse forward bias and collector emitter junction is in reverse bias, so that it happens in active region. So that whenever it is operated in active region, transistor acts as a amplifier.